In the last video, again, these are for October 19th, October 20th, we finished here with the arcsine relation. Now, here's an issue. If I were to ask, what is arcsine of 0? Well, if I plug in 0 for my x value, I could get out 0 because it touches there. I could get out pi. I could get out 2 pi. I could get out negative pi, negative 2 pi. Similar thing if I plug in 1. If I plug in 1, I might get pi over 2. I might get negative 3 pi over 2. And that is a problem because if you look at the top of the page or if you refer back, what we really want to do is create functions. And this is not a function. To give you an example, here if we have f of x equals square root of x, if I plug in 16 here, the square root of 16 is 4. And what we're really saying here is that 4 squared gives us 16. We're reversing the square. However, negative 4 squared also equals 16. But we don't say that the square root of 16 equals negative 4, even though negative 4 squared does equal 16. And the reason that's the case is for every input that we have into a function, if it's a function, every input that we have into a function, there has to be one output. If there was this multiple output, we would not have a function. So for every one input, we have to have one output. That's extremely important. And so with our arcsine graph that we have so far, because we plug in one thing, we have a lot of different outputs. If I plug in one thing, multiple outputs. What we do is instead of taking all of this dotted line, what we do instead is we take a segment of it. And so we only take this segment from here to there. And that is our arcsine function. The dotted pieces we do not care about anymore. It's only this solid little segment that is what we care about in terms of defining the arcsine function. Now in class there's a lot of questions on why. Why are we doing this? Well, here's the real reason. If I plug in 0 now, I don't care about this one anymore, the pi, because it's on the dotted piece. I don't care about 2 pi. I don't care about negative pi or negative 2 pi. I only care about this one because that's the only one that's on the solid piece. So it's no longer any of these four. Arcsine of 0 is 0. Similarly, if I plug in 1, it could have touched pi over 2 or negative 3 pi over 2. But because negative 3 pi over 2 is in this dotted piece, I don't care about that one. I only care about what's on this solid portion of the function or of the graph, because that's what makes it a function. So arcsine of 1 is pi over 2. It is not negative 3 pi over 2. So in taking this shortened piece, what's happening is if we have one input, then we will get one output every single time. And that's really what we want here. We want one input, one output. If I plug in 0, I get 0, nothing else. If I plug in 1, I get pi over 2, nothing else. Okay, whew, man, a lot's going on. So we have defined our arcsine function. And after we did this in class, what we talked about is if we have arcsine of x, we want to define its domain and its range. Well, if I'm talking about the domain, we're talking about all the x values the function can take. If I look as far left, it's going to -1. It's continuous and it stops at +1. So the domain for arc sine is -1 to 1. Similarly, if we look at the range, the y values, I don't care about the dotted piece. I only care about this solid portion. And so how far low does it go? It goes down to -π/2. How far up does it go? π/2. It does touch at each of those, and I want to include them. So everything in between -π/2 to π/2, including those two values. That would be our domain and range for arc sine. Excuse me. Let's compare that to sine of x. So again, sine of x and arc sine of x, they are inverses. Domain for sine was -infinity to infinity, because remember, it goes forever in both directions. The range for sine, it only went down to -1, and it went up to 1, and it touched at each of those. So that was the range for sine. So domain and range. Why am I bringing this up? Well, the reason is because if these two are inverses, because sine of x and arc sine of x are inverses, then the domain and ranges should switch. And if we look at the range for sine, it does become the domain for arc sine, which is what we want. We want the range to become the domain for arc sine, which is good. But the domain here does not become the range for arc sine. And we need to talk about why, because that's a huge piece of what's happening and like the content from this day, from this lesson. If we took the dotted line, all of this, then the range for arc sine would be -infinity to infinity. However, we only take this piece. We only take this piece so that we have one output for every input. And the way I described it in class is instead of going from -infinity to infinity, we shortened it. We shortened it only to this section here, so this range is shortened. So that, and the main reason is so that arc sine is a function. Okay? If the range was -infinity to infinity, then we would be taking all of this, and we would be having an issue with these values. But by shortening the range, by only focusing from -π/2 to π/2, by doing that, we ensure that arc sine stays a function. And that is huge. We need to have these to be functions so that when we input one value, we get out one value. And that is the main thing from what we did in class. Now, there'll probably be a third video. On that third video, I'll define arc, cosine, arc, tangent. Really interesting, different concepts here. So if you have questions, please pause, rewind, ask those questions. I would love to answer those if you have those.